Hello again, guys. This is our third part for tonight here. This is exam 2, questions 11 through 15. It'll be really quick because we're going to skip a few of them, okay? All right, the first one might be hard for you to read. I apologize. But it says, owner of a daycare chain wished to determine the proportion of families in need of daycare for Brockville. Brockville is estimated to have 1,000 families. Owner of the daycare chain randomly sample 50 families and find that 60% have a need for daycare services. Which of the following is a condition necessary for constructing a confidence interval for a proportion that has not met? Okay, so we know our conditions are random sample, independence, and nearly normal. So first of all, random sample, that's usually the violator, like it was on a previous question on this test. Okay, but they said they took a random sample of 50 families. That sounds fine, okay? Sample size is less than 10% of the population size. Okay, the sample size is 50. It's less than 10% of the population. That satisfies independence. And it says count of those in daycare and are 10 or more. Okay, and we want P times Q, the percent of families that want it, okay, to be, let's see, 10 or more. Sorry. Yeah, so 60% of 50 is going to be more than 25. Sorry about that. And 40% of 50 will also be more than 10. That satisfies that condition there. And then the distribution of the family is approximately normally distributed. Okay, that's what we're doing by the condition. We're assuring that. Okay, all those seem to be okay. So E is the correct choice there. All conditions necessary for constructing an interval for the proportions seem to be met. That would satisfy our conditions. So we'd be good to go on that problem. All right. Sorry about that pause there. I was thinking about something. Number 12. Which of the following does not contain a source of bias? A politician would like to know how her constituents feel about a particular issue. As a result, her office mails questionnaires about the issue to a random sample of adults in her political district. Okay, so that's going to suffer the questionnaire. Some of them are going to be returned, some are not. Okay, and again, people with strong opinions will be the ones that'll be submitting those. So it'll probably suffer from non-response bias when people don't respond back, and she'll only get the responses of those who are have strong opinions about that. Okay, a company uses a telephone directory, okay, to randomly select adults for a telephone survey to gauge their feelings toward items manufactured by the company. Well, a telephone directory is fine, except it doesn't represent everybody. That study would suffer from undercoverage. Homeless people, teachers, I'm not in there, police, fire, all those groups are underrepresented, so that would have undercoverage as a bias there. Finally, C, an interviewer selects a random sample of individuals to question about a particular issue. Since some of the individuals are not informed about the issue, the interviewer gives background and his personal view. Giving his personal view is going to be slanting the responses. Okay, so that is going to be response bias. It's going to give biased responses back because he's influencing those responses. All right, finally D, a news show asks viewers to call a toll-free number to express their opinions about a recent high-publicity trial. Who's going to call? Again, volunteers are calling. They're going to call with strong opinions. That's not going to be a good representation of everybody. 1,000 tickets. 1,000 numbered tickets are sold at a fundraiser. 5 numbers are randomly chosen from all of them, and the individual with the winning ticket each win $10. Everyone has an equal chance of winning. There's nothing going on there to create any kind of a bias, so E is the correct answer for that. All right, 13 is a good one. It's probability. Okay, and it's been a long time for this one here. Okay, so we have our chart here, and remember, like that 12, that represents people who, and let's go to the beginning here, sorry. Cause of death and age of the deceased are recorded for these patients. Okay, so these 12 represent people who died by an accident and being the key, are between 25 and 34 years of age. Okay? And the probability of someone dying from an accident would be 60 out of the total 454. The probability of dying of an accident and being in this age group would be 12 out of 454. Okay, the only time it's not out of 454 is when they ask you a given type of problem, which is going to happen in this problem. We'll come back to this in a minute here. Okay, here we go. Use these values to estimate the probability that a person at this hospital died as a result of an accident. Okay, we're finding that probability if it's known, given, that the person was between 45 and 54. Okay, so I'm asking, or they're asking here, the probability that they died as an accident, given, okay, it's known the person was between 45 and 54. Okay, so that's the problem we're working on right now. Let's go to my, okay. All right, here we go. Probability of an accident given, it's out of the 45 to 54 group, okay, means automatically that it's the probability of accident n 45 to 54 divided by the probability of 45 to 54. So the probability of accident n 45 to 54, let's have a look at that. So accident n 45 to 54 is 12 out of 454, or you could just say 12 even. Okay, and then the probability of being an accident is 60 out of 454. Hope I got that right one. Oh, sorry, the probability of 45 to 54, that is 123 out of 454. Okay, so those are going to be the values we're using here. So accident and 454, 12 out of 454, you could just say 12. Okay, it's 12 out, and compared to the other one, the probability be in that group is 123 out of 454, or just 123. You can cancel those 454s, okay, and that is a mean 0.098, which is choice B on that problem. Okay, so that was a good one. Definitely need to see that. They'll ask you something to do with that type of a thing on the test for sure. All right, let's get rid of that. Okay, all right, this one, I'm just going to say we're going to skip. This is 14. We're just going to skip that. Okay, the correct answer down here is a linear regression t-test. There's a little thing at the end that I've opted, and I do every year, not to teach you so that we can review all the main stuff. It's very obscure, so it's like a whole nother chapter, and we don't have to learn that. If you do good on the other material, you're in much better shape. Our time is much better spent reviewing all the main ideas than looking at this one little thing and making us not have time to review. Okay? So we're going to skip that one. And then 15 is really similar, okay? So 15, you need to know about 15, but not this particular set of problems I believe that they gave you, okay? Which of the following does not represent a probability density function? Okay, so a probability density function, think about this. We always are working on that. That's all the probability under this function, and a function that has like a certain math equation that is that function, okay? And the probability under there should equal 1. It cannot equal more than 1, okay? And depending where you are in your math, okay, you might understand that this one here is more than 1, so that's the one that could not represent a probability density function. If you don't now, don't worry about that. Those are odd choices, okay? So that's something by our book, but not normal. But if you see one that the probability is greater than 1, that obviously can't be the case, and that would be the correct choice for deciding which one would not be a probability density function. And that is it for 11 through 15. So that's a quick one. So I'll come back in a moment and we'll pick up the last grouping for our 1 through 20.